to my channel. My name is Prachi Sharma, and in today's session we are working on the most important questions of the chapter Analytical Chemistry. So if you are still struggling with this chapter, I can assure you one thing, that it's not necessary that you have to learn all the equations. Even if you're not doing so well in the equations, but you understand the concept, you are good to go for this particular chapter. So just because you're not able to cram up the equations does not mean that you leave out the chapter entirely. So stay tuned in this video till the end. We will be focusing on a lot of questions, and more than 50% of the questions you do not need equations for that. So without wasting any time, let's get started. Alright students, so let's get started with today's session. I hope the screen is clearly visible to you. Now, for all the questions, because we will be covering about 38 questions, now we'll be taking reference of these two charts. If you have not done this chapter at all, I would suggest that you check out the video on the channel in which I am telling you how, and I'm teaching you how to learn this chapter. It is in 3 parts and it covers everything, that is anion detection, cation detection, and also the last part, that is alkali. Now let's understand what is happening in this one. So this is the NaOH and NH4OH chart. So in this case we are talking about your ion. When it is reacting with NaOH, what kind of precipitate it forms, and if it is in axis, what happens. Same thing is happening in this entire chart. We have all the colored precipitates, and whether it is soluble in axis or insoluble in axis, all of that is here. If you learn this chart, you'll be able to solve all the questions which are based on this except the equations. So if there is anything regarding observation questions, you are good with that. If they are asking about what kind of precipitate is coming out, or they are asking you to identify the ions, you will be good for everything around that except the equations. Similarly, we have the radical names. This is your cation detection. Anion detection. So in this case, what would happen is you have all the ions present here. You will have carbonate, sulfide, chloride, and all the information is in this chart itself. So no matter what kind of questions comes out, if you are good with this particular chart, you will be able to answer all the questions. So if you want, you can take a screenshot of this. While we are doing the questions, you will have reference from the questions. Same thing for this one. You can pause and take a screenshot, and when we are doing the questions, you have a reference with you. So let's get started with the questions for today. Let's get started with the first one. So the first question says that, state your observation in the following case when excess sodium hydroxide is added to calcium nitrate solution. So now what would happen in this case is, you go back to the chart. So what would happen in calcium nitrate? So we are talking about calcium and we are talking about sodium hydroxide. So for the first few questions, I'll tell you how we use the chart. So I'll come back on the chart, I'll copy it and take it up. So just bear with me for one quick minute and then we'll be good. Okay. Okay, now I'll just paste it up there and then we'll take it as reference along with the questions. Alright, so I have the chart right here. Now the question is asking about sodium hydroxide. So if I zoom in the chart, we are in sodium hydroxide chart and they're talking about calcium. So if you think about that and you take a reference, so we are talking about calcium and we are talking about sodium hydroxide. So we are right here in this area. Alright, so we are talking about the first section, which is this one. So you have calcium and sodium hydroxide along with that. They are asking what is your observation. So your observation will be that a white precipitate is formed which is sparingly soluble or insoluble in excess of sodium hydroxide. So this is your observation. So this is the first question that we were doing. State your observation in the following case when excess sodium hydroxide is added to calcium nitrate solution. Okay, so when they are saying when excess, so what you'll say is when we have excess, then that particular, so initially a white precipitate is formed which is insoluble in excess of sodium hydroxide. So that is your answer for this question. Let's try the next one. Give a chemical test to distinguish between calcium nitrate solution and zinc nitrate solution. So we'll come back on the chart. So we are talking about calcium nitrate and zinc nitrate. So you pick up this one and the first one. You can take up anything. Either you take up sodium hydroxide or you take up ammonium hydroxide, whatever you're comfortable with. You can, for calcium, let's say you took sodium hydroxide. So you'll say a white precipitate is formed which is insoluble in excess of sodium hydroxide. And then you look at zinc. In this case, you will say a white PPT is formed which is soluble in excess of ammonium hydroxide. So, I'm sorry. So that will be your difference between the two. Let's move ahead to the next question. State two relevant observations for each of the following cases. Ammonium hydroxide solution is added to copper nitrate solution in small quantities and then in excess. So we are talking about copper and ammonium hydroxide. Okay, we are back on the chart. Ammonium hydroxide. So we are in this one. Okay, so ammonium hydroxide, we are in this chart. Then we come down. In this one, if you see, I'm not sure why this is not working well. Alright, so now this should work. So when I'm in ammonium hydroxide section, in ammonium hydroxide we are differentiating, we are talking about, the question is asking about copper nitrate, okay, observation for copper nitrate, okay. So we are talking about copper, which is right here. In ammonium hydroxide, you get a pale blue precipitate. They are asking two observations. So your first observation will be a pale blue precipitate is formed. Then the second observation will be that it is soluble in excess of ammonium hydroxide. So that will be your answer. Let's move to the next part of the question. Ammonium hydroxide solution is added to zinc nitrate solution in minimum quantities and then in excess. Okay. So we'll come back on the chart. We are talking about zinc. So first of all, ammonia. So you are on this line. Then zinc. So you are on this line. So your first observation will be a white PPT is formed. Second observation will be soluble in excess of ammonium hydroxide. So let's move to the next one. Name a gas which turns acidified potassium dichromate clear green. Okay. So this is not related to that particular chart. So I have also covered the different gases and their tests in one of the analytical videos. So make sure that you check out that if you have any issues with it. Now, as we have laid base about everything, now we'll be going fast with our questions because I need to cover about 38 questions in this particular session. So let's be quick. So name a gas which turns acidified potassium dichromate clear green. That will be sulfur dioxide. Let's move to the next one. State one observation for each of the following. Excess ammonium hydroxide solution is added to lead nitrate solution. Let's quickly come back on the chart. So we are in excess ammonium hydroxide, which is the last column. In this case, they're talking about lead, which is the last column over here. So your observation will be insoluble. So you come down like this and then you come right like this. So that is how you map out your answers from the chart, which is very quick if you are well versed with this particular chart. Now I won't be taking reference again from this chart because it takes up a lot of time. Now we'll be going quicker with the questions. So let's come back. Next is sodium hydroxide solution is added to ferric chloride solution at first a little and then in excess. And you're supposed to give one observation. So your one observation will be reddish brown precipitate which is insoluble in excess of a sodium hydroxide solution. I do have the chart open with me here so that we can go a bit quicker with the questions. Now next is identify the anion present in the following compounds. Compound X on heating with copper turnings. Okay, so for this particular anions, I do have the second chart, which is right here. Okay, so this is for anions. Now I'll read the question from the page that I have here for the questions. The question says compound X on heating with copper turnings. So we have copper turnings and concentrated sulfuric acid liberates a reddish brown gas. So we'll talk about reddish brown gas. So which one is reddish brown gas? Okay, you do not have that one here. You have a you have the reddish brown gas. You have it right here. So a reddish brown gas with concentrated sulfuric acid and copper turnings gives you a reddish brown gas. So what is your compound X? Your compound X is nitrate. And what is the gas evolved? That is nitrogen dioxide gas. Then the second question is, when a solution of compound Y is treated with silver nitrate solution. So do we have that here? Is a white PPT is obtained, which is, okay, it's not from this particular one. When a solution of compound Y is treated with silver nitrate solution, a white PPT is obtained, which is soluble in excess of ammonium hydroxide solution. Okay, this particular question is from nitric acid. Yes, it is from nitric acid, in which case we study that silver nitrate is not soluble. So you get a white precipitate and it is not soluble. It is soluble in excess of ammonium hydroxide. So let me show you the question first. Alright. Now when a solution of compound Y. Now this one we have also covered, in which we are doing the observations. So we do have two different videos uploaded on the channel, in which we have the observations only for the 4 chapters that you have compounds, study of compounds. So let's quickly look at this. So this is when a solution of compound Y is treated with silver nitrate solution, a white PPT is obtained, which is soluble in excess of ammonium hydroxide solution. So in this case, this particular compound is your chloride. Now the next is compound Z. Compound Z on reacting with dilute sulfuric acid liberates a gas which turns lime water milky, but the gas has no effect on acidified potassium dichromate solution. That would be carbonate. Your compound would be carbonate. Now the next is compound L on heating. A compound L on heating with barium chloride solution gives a white PPT insoluble in dilute hydrochloric acid or dilute nitric acid. So that will be your sulfate ion. That will be sulfate, SO4 2 minus. Next is state one chemical test between each of the following pairs: sodium carbonate and sodium sulfite. Okay. So again, since you have carbonate and sulfite, you can take up reference from that particular chart and you can say that, okay, let's add dilute hydrochloric acid to both the compounds. For sodium carbonate, you will get carbon dioxide gas. For sodium sulfite, you get SO2 gas. Okay. Then next is ferrous nitrate and lead nitrate. Again, take reference from the same chart. In this case, you can add sodium hydroxide to both the compounds. Ferrous nitrate will give you a dirty green PPT, which is insoluble in excess, and your lead nitrate will give you a white PPT, which is soluble in excess. We already took reference of the chart. Next is manganese dioxide and copper oxide. So in this case, you can add hydrochloric acid to both the compounds. Manganese oxide will give you a brown colored solution and copper oxide will give you a blue colored solution. For any doubts and queries, students, you can definitely reach out to me either in the comment box. You can also write me an email on psclassesicsc@gmail.com, or you can reach out to me on the Telegram channel. So make sure if you are getting stuck anywhere, you can definitely ask me your doubts. Alright students, let's move ahead to question number 7. So I do have my charts open up right here, so I am taking reference from the charts to make it a bit quick. So the question says, distinguish between the following pair of compounds using the test given in the brackets. This is a very common type of questions that you get. So iron 2 sulfate, iron 3 sulfate using ammonium hydroxide. So iron 2 sulfate will give you a dirty green PPT, which is insoluble in excess of ammonium hydroxide, and iron 3 sulfate will give you a reddish brown PPT which is insoluble in excess of ammonium hydroxide. Let's move to the next one. Lead salt and zinc salt using excess of ammonium hydroxide. So for lead and zinc, both of them you get a white PPT. For lead it is insoluble in excess and your zinc is soluble in excess. Let's move to the next question. Next question is, what do you observe when ammonium hydroxide is first added in small quantity and then in excess to a solution of copper sulfate? So for copper sulfate, what will happen is you will get a pale blue precipitate which is soluble in excess and gives you an inky blue solution. Okay students, let's move ahead to the next question. Sodium hydroxide is added to the solution containing the ions mentioned in the list X. List Y yields the details of the precipitates. Match the ions with these with the colored precipitates. Okay, so let's start with the first one. So your lead. So let's start. You have lead, zinc, iron, zinc, copper, calcium. And on this side you have reddish brown, white, insoluble in excess. Okay, and your reference is sodium hydroxide for the chart. So you have sodium hydroxide being added. So for lead salt, what would happen is you will get a white soluble in excess. So white precipitate which is soluble in excess. You can either pick up D or E since both of them are same. Now the next is iron. For iron you will get a dirty green. So iron 2. So you will get a dirty green which is C. Then for zinc you again get a white PPT for this. So you can get D or E. So zinc will be D or E. Then iron 3 will give you a reddish brown. So that will be this one. Then copper 2 plus. So copper will give you a blue. Of course, copper will always give you a blue. And then what are we left out? We are left out with calcium white insoluble in excess. So I hope that is clear. Let's move ahead to the next question. Choose the correct answer from the options given below, and your hydroxide of this metal is soluble in sodium hydroxide solution. So lead is soluble. If you take reference from the chart again, lead is soluble. Let's move ahead to the next question. Question number 11. 3 test tubes containing calcium nitrate, zinc nitrate and lead nitrate solutions respectively. Each solution is divided into 2 portions, A, B and C. Okay, A and B. Describe the effect of adding sodium hydroxide to each portion, and the second is adding ammonium hydroxide. So first you add little and then in excess. That is pretty simple. How you will write this answer in the exam? So what you will do is, you will mention salt, then you will mention in small amount, and then you will mention in excess. And you will do this for both the parts. So right now I am doing this for sodium hydroxide. So you will make 2 charts, sodium hydroxide, and the other one will be, let me use a different color. So I'm using sodium hydroxide right now, and then you'll make a different chart for ammonium hydroxide. So for the first one you have calcium. So you have calcium, zinc and lead. So calcium, zinc and lead. So in small quantities, of course, all 3 of them will give you white PPT. So all 3 you will write white PPT. And then calcium is insoluble and other 2 are soluble. And that's it. Now students, one thing I will assure you is that if you stick around in this video till the end and you are able to follow all the questions, that is it. You do not need any more practice for analytical chemistry. These are all the possible questions from this chapter. So if you are able to stick up till the end and learn all these questions well, you are 100% gonna score, or you won't be losing any marks in this chapter. Let's move ahead to question number 12. What do you observe when sodium hydroxide solution is added to zinc sulfate till it is in excess? So zinc, of course, will give you a white PPT which is soluble in excess of sodium hydroxide. You are given the 3 white powders, calcium carbonate, lead carbonate and zinc carbonate. Describe the tests you would carry out in solution to identify the metal in each of the above compounds. Indicate clearly how you would prepare the solutions for the tests. Okay, one thing is that in this case we missed out the B part, that was adding ammonium hydroxide. So for ammonium hydroxide, if you have calcium nitrate, no visible reaction happens for that. Zinc nitrate and lead, both of them will give YPPTs. For zinc, it is soluble in excess of ammonium hydroxide. For lead, it is insoluble in excess of ammonium hydroxide. So that's done. Let's move ahead to the question number 13th. So in this case, what would happen is calcium carbonate dissolves in dilute nitric acid. So to the clear solution, when ammonium hydroxide is added, there is no visible reaction. That is what you will mention for calcium carbonate. Then for lead carbonate. For lead carbonate, you will dissolve it in nitric acid. Now in this solution, you can add ammonium hydroxide. You get a white PPT which is insoluble in excess. Okay. Now we come on the third one, zinc carbonate. You added it into dilute nitric acid. You get a clear solution. In this clear solution, add ammonium hydroxide. You get a white PPT which is soluble in excess of ammonium hydroxide. Okay students, I hope this question is clear to you. Let's move ahead to question number 14. Now I hope you are able to notice that till 14th question, so far we have not done any equations, but you were still able to solve 13 questions so far. Let's move to this one. Write the equation for the following reaction. Copper sulfate. What is copper sulfate? CuSO4. Added to sodium hydroxide solution. Added to sodium hydroxide solution. So you get CaOH whole twice plus Na2SO4, and that's it. But you have to balance it, so you can check the balancing later. Let's move to question number 15. Sodium hydroxide solution is added to solution A. A white PPT is formed which is insoluble in excess of sodium hydroxide solution. What is the metal ion present in solution A? So that will be calcium, because in calcium you get a white PPT which is insoluble in excess of sodium hydroxide. So that is calcium. Now next is when ammonium hydroxide is added to solution B, a pale blue. So whenever you see blue, you should lean towards copper and then completely read it, because sometimes it could be a trick question and they may give you some information in which you are not getting anything. So you will say no possible reaction. So that can also happen. So make sure that you read it thoroughly, but of course lean towards copper. When ammonium hydroxide is added to solution B, a pale blue precipitate is formed. This pale blue precipitate dissolves in excess of ammonium hydroxide, giving an inky blue solution. What is the cation present in solution B? What is the probable color of solution B? So that will be copper. And what is the color of solution B? It is blue. Okay students, let's move ahead to the next one. So the next question is, using sodium hydroxide solution, how would you distinguish between zinc nitrate solution and calcium nitrate solution? So it is simple. Both of them gives us a white PPT. Calcium nitrate won't dissolve. The PPT will not dissolve in excess. Zinc will dissolve in excess. Now the next is iron 2 sulfate and iron 3 sulfate. So iron 2 sulfate with copper with sodium hydroxide will give you a dirty green precipitate. And then for the second one, you will get a reddish brown precipitate. Now the third is lead hydroxide and magnesium hydroxide. So sodium hydroxide, when we add it to lead hydroxide, it dissolves. Whereas when sodium hydroxide you add it to magnesium hydroxide, there is no visible reaction, because magnesium hydroxide will remain insoluble. Okay. Let's move to the next question. Now the next question is, how does ammonium hydroxide help in distinguishing between these? So similarly, you take a preference from the chart again. So we have iron 2 chloride. So that will give you a dirty green precipitate which changes to reddish brown. And for the iron 3 chloride, you will get a reddish brown PPT directly. Now the second is zinc nitrate and lead nitrate. Zinc nitrate on reacting with ammonium hydroxide will give you a white PPT which is soluble in excess. And for lead nitrate, you get a white PPT which is insoluble in excess. Then the third is lead hydroxide and zinc hydroxide. So lead hydroxide will give you, lead hydroxide remains insoluble in ammonium hydroxide, whereas zinc hydroxide dissolves in ammonium hydroxide. That is one important difference. Let's move to the next one. Question number 18. What are the color of the precipitates when ammonium hydroxide is added to the following solutions? So iron 2 chloride, you get dirty green PPT. The second one is iron 3 chloride, you get a reddish brown PPT. Lead nitrate, you get a white PPT. Zinc nitrate, you get a white PPT. Copper nitrate, you get a bluish, blue PPT. Now the next question is, write balanced equations for the following. So unless and until in this chapter they are not directly asking you the equation, you are not supposed to, or it's not necessary to give out the equations. So you can solve maximum questions. According to me, I have seen students solving about 80% of the questions without learning equations. So let's start with the first one. Sodium hydroxide. I'll quickly write the equations as we go along. So sodium hydroxide is reacting with copper sulfate. So CuSO4 plus sodium hydroxide NaOH will give you CuOH whole twice plus Na2SO4. Now next is ammonium hydroxide is added to iron 2 chloride. So in this case that will be NH4OH plus FeCl3. So this is iron 3 chloride. FeCl3 giving you FeOH whole thrice plus NH4Cl. Next is sodium hydroxide is added to ammonium 2 chloride. So that will be NaOH plus FeCl2 giving us FeOH whole twice plus NaCl. Next is sodium hydroxide reacting with calcium nitrate. So calcium nitrate will be CaNO3 whole twice plus sodium hydroxide is NaOH, which will give you CaOH whole twice plus NaNO3. Now the next is, you have zinc hydroxide solution is added to zinc sulfate, first a little and then in excess. So you have to give in two equations in this one. So first in little and then in excess. So zinc sulfate ZnSO4 plus NaOH will give you ZnOH whole twice plus Na2SO4. Then you have it in excess. So ZnOH whole twice plus NaOH, which will give you Na2ZnO2 plus H2O. So students, make sure that you're paying attention on all the details that we are discussing here. I have not balanced any of the equations. You can try balancing on your own. If you're getting stuck, you can reach out to me. Let's move to the next question. What do you observe when ammonium hydroxide is added to copper sulfate solution, first in little and then in excess? So when you have ammonium hydroxide, when you're adding drop by drop and you're adding to copper, so first you get a blue PPT which dissolves in excess of ammonium hydroxide and gives you a inky blue solution. Move ahead to the next one. Sodium hydroxide is added to zinc sulfate, first in little and then in excess. White PPT is formed, soluble in excess. Calcium nitrate, sodium hydroxide. White PPT is formed, insoluble in excess. Sodium hydroxide and iron 3 chloride. Reddish brown PPT is formed, insoluble in excess. Ammonium hydroxide to lead nitrate. So white PPT is formed, insoluble in excess. Okay. Move ahead to question 21. Identify the cation in each of the following case. Sodium hydroxide solution when added to solution A gives reddish brown PPT. So when you get reddish brown PPT, it is Fe3+. So Fe3+, ferric ion. Next question. Ammonium hydroxide when added to solution B gives a white PPT which dissolves in excess. Your answer is zinc. Next is sodium hydroxide added to, okay, you get a bluish white PPT, insoluble in excess. They're talking about copper. Next question is ammonium hydroxide gives you a dirty green PPT, changes to reddish brown after some time. They're talking about Fe2+, ferrous ion. Ammonium hydroxide solution when added to solution E gives bluish white PPT which dissolves in excess and gives a deep blue solution. They are talking about cupric. So Cu2 plus. Let's move ahead to question number 22. Compound A on reaction with dilute hydrochloric acid produces a colorless, odorless gas B with brisk effervescence. Identify the gas B. The gas will be carbon dioxide. Then they are saying identify anion in compound A. That will be carbonate. CO3 2 minus. Give confirmatory test for the gas B. So gas turns lime water milky. That's your confirmatory test, and you are required to write the equation also. So that will be CaOH whole twice plus CO2 gives us CaCO3 plus H2O, and this is the white PPT which turns it milky. Let's move to the next question. Next question says green colored amorphous salt. Amorphous salt I have already taught you in one of the videos, so I hope that is clear. Green colored amorphous salt A on reaction with dilute sulfuric acid produces a blue colored solution. So lean towards copper. The blue colored solution on treatment with alkali C produces pale blue PPTD. On adding excess of C, the PPT dissolves to give a deep blue solution E. In this context, answer the following questions. Identify A, B, C, D and E. So first thing is we need to write all of them. So what we'll do is I'll write A, B, C, D, E. And then we read it again and identify each one of them. Okay. Green colored amorphous salt A. So what salt are we talking about? We are talking about some salt of copper. So for now, and it's an amorphous salt. So first I'll just write copper here and I'll identify the salt completely later. Produces a blue colored solution B. So this is also copper. So this should be copper carbonate and this should be copper sulfate. The blue colored solution on treatment with alkali C produces, now this alkali C will be ammonium hydroxide. Next is adding in access in C, PPTD. So your PPT that is produces copper hydroxide. Copper hydroxide. And the gives a deep blue solution E. This would be tetraamine copper hydroxide. So I'll just write it here. Tetraamine copper hydroxide. Now second is A soluble in water? A is insoluble in water. Copper carbonate is insoluble in water. Now the third question says write all the equations involved in the above reactions. So let's see. So the first thing will be you have A. So you have copper carbonate CuCO3 reacting with sulfuric acid which gives you CuSO4 plus H2O plus CO2. This is your A, this is your B. Then you have C. So in B, you are adding C, that is CuSO4 and your C was ammonium hydroxide. NH4OH will give you CuOH whole twice plus NH4 whole twice SO4. So this is your B, this is your C and this is your D. Okay. Now what would happen in this case is in this D, that is CuOH whole twice plus 4 NH4OH will give you CuNH3 whole 4 OH whole twice plus 4 of water. So 4 of each. So that's it. These are the equations involved, and this tetraamine, this is your E that we were talking about. Now let's move to the next question, question 24. From the list of the substances given below, choose the substance which fits the given description. Ammonium chloride, calcium hydroxide, lime water, ammonia, concentrated HCl, zinc carbonate, carbon dioxide, sulfuric acid. Okay. Substance A is formed when water is added to calcium oxide. When you add water to calcium oxide, substance A is formed. So you have calcium oxide and you're adding water to it, so that should be calcium hydroxide. So your answer A will be calcium hydroxide. A is calcium hydroxide. Then substance A on reaction with substance B produces alkali gas C. So what is your alkaline gas C? That is always ammonia. So if you have to identify C, that is ammonia. Substance A on reaction with substance B. So substance A is calcium hydroxide. It is reacting with substance B to give ammonia. So that will be ammonium chloride because an option is already given to you. So ammonium chloride is B. Calcium hydroxide is A. Ammonia is C. Now next is alkaline gas C on reaction with D produces dense white fumes. So ammonia always gives you dense white fumes with HCl. So your concentrated HCl will be D. Substance E on heating alone produces acidic gas F. So that and a yellow residue is left behind. So yellow residue is left behind can be sulfur. So if that is happening, that means this is it for today's session. We have successfully covered all the possible important questions of the chapter Analytical Chemistry. If you still have any doubts or concerns, you can reach out to me and I will definitely respond back. So thank you so much. I hope you have a wonderful day.